Standard 8, waves 1. So we start this standard out by remembering the waves model. So this represents 1 second of time, and this is the equilibrium. Okay, and then we draw our wave. It goes up and down over that equilibrium point. And then we need to remember all the names for this. The first one is wavelength. And the second one is amplitude. And it just comes from this point to the top. That's amplitude. So it's not the entire way down, because there's no way to measure it down here. There's nothing right here. So you just go from equilibrium to up. That's amplitude. So we've got positive amplitude here and negative amplitude there. This is a trough. And up here is a crest. And so we measure the frequency of waves by how many waves there are per second. So this is like represents time, 1 second. And you have 1, 2, 3 waves, almost 3.5. So you could put maybe 3.5 hertz. That's how we measure it, hertz. And that just means seconds, or number of waves per second. And then they call that number of waves per second, they call that hertz. And that's a measurement of frequency. So this is the model that you guys were required to draw on your test. Now we just got to remember, what does frequency mean and what does amplitude mean? That was really hard for people to keep track of. So we're going to just go ahead and make a table here. And we're going to do different waves. Sound waves, light, and water. And then over here we're going to do frequency, amplitude, and then we're going to identify low frequency, high frequency, low amplitude, and high amp for each of these. Okay, so when we're talking about frequency and sound, we're talking about pitch. We're talking about frequency for light, we're talking about color. When we're talking about frequency and water, we're talking about the number of waves over time. So when waves come faster along the beach, surfers like that because they like the challenge of more waves. If they're just sitting there on their surfboards for a long time, that means the frequency of waves is not very high. But they like it when the waves, the large waves, especially with high amplitude, are coming faster, which is more higher frequency. Well, I guess we'll get to that down there. Amplitude, for sound, we're talking about volume. It's the volume on your cell phone that it's basically increasing the amplitude. Okay, when light is, when we're talking about light amplitude, we're talking about brightness of the light. When we're talking about amplitude of the waves, we're talking about the height of water waves. So when surfers get out there, they want to have high amplitude water waves. Okay, low frequency sound is basically a deep voice or low pitch, a low pitch deep voice. And we practiced that in when we did our sound labs, deep voice, right? And with those boom, I think they're called boom whackers, where some of them that were, was it the longer ones that were more low pitched than the shorter ones. Okay, and then low frequency light is dim, a dim light. And low frequency water waves are basically less number of waves, or lower, let's just say low number of waves. So that's going to be like smooth waters. And then if we have high frequency, we're going to have a high pitched voice. If we have high frequency light, that's a certain color, and we know that that's purple. And then if we have a high frequency waves, we just have high number of waves. So for a surfer, that's good, like we said, but if you're on a boat out in the ocean, it's choppy. It's when things are choppy. If you water ski, that's when there's high frequency in the water of waves, then you're going to experience choppy waters. Okay, low amp, that's low amplitude. If we're looking at sound, it's going to be a quiet voice, somebody who's whispering. That's quiet. And then a low amp light. Sorry, I did this wrong. A low amp light is dim. This is red. That's the low frequency light. When we're talking about frequency, let's remember it's color. When we're talking about amplitude, we're talking about brightness. So low amp is dim. And then with low amplitude waves, we just have low waves in height. So they're just not as large, just, small waves. And then high amplitude is when our sound is loud. And we're talking a really loud voice. Okay, and when light is quote unquote loud, we're talking about bright lights. When the amplitude for light is when light amplitude is high, the light is bright. And then for waves, this is just a high wave in height. Very large. Okay, so that basically straightens it all out for us. You need to understand that to answer the questions. Greatest energy waves, right here and here, both these. Frequency means there's more energy. So like on the test, if you remember, you had waves. It said which one has the highest energy. Then you're going to want to identify a wave that has both high frequency and high amplitude, as opposed to a wave that, like this one, even though it has high amplitude, if it doesn't have as much frequency, then it's not as much energy. It's got to be both. And again, this one that just has frequency but not as much amplitude, that's not going to be as high energy as this example here. Okay, amplifiers. So when we use amplifiers for our sound waves, like at a concert or something, We want everybody to be able to hear the sound all the way to the very back row. We're gonna want to amplify the sound, make it higher amplitude, louder. So the people in the first row will experience it extremely loud, but the point is the people in like the very back row, that the hope is that they also will experience, because as a wave travels, if it starts with high amplitude, it's gonna just eventually, because it runs out of energy. Energy gets transferred to the molecules it's hitting, and displaces them and turns into a little mechanical energy, and so it loses its wave energy with the sound. So by the time it gets to the back of the row, has less energy, and then that means it's quieter and not as loud. So we want to use amplifiers at concerts so everybody can hear it. And usually they place speakers like halfway down the row, somewhere here, so that it's not blasting everybody out on front row. But this guy, this speaker enables the waves to travel, and so they can hear it with as much amplitude as the people in the front row are hearing it. Okay, so that's waves 1 and